Hi again. So this is a very interesting video where I'm going to show you component symbols that you can find on computer motherboard. So we're gonna see many symbols, and upon end of this video you will be able to identify any symbol that you can find while studying computer schematic. So let's get started. So I began from the page 10 because the first pages are just the index, the block diagram, the power sequence, and the function diagram that we have seen before. You can check my YouTube channel, you will find the videos about block diagram, etc. for the laptop. So now we're gonna see step-by-step symbols and its meaning. Okay, so let's get started. So this first shape, as you can see here, or symbol, is for an chipset. Is for a chipset. Why? Because here we have many square inside it. This square's main controller. If you focus here, we have here, as you can see, UC, control unit. Okay, this is the CPU or the processor. So here, this lines here, as you can see, means signals. Okay, all this means signals. So those are resistors, as you can see. Okay, so here we have another resistor, but this time this is a network resistor. Okay, so the definition of a network resistor is a resistor that combine or contain many resistors. It could be 2 resistors, 3, 4 or more. Okay, so the engineers use or designer use this kind of resistor, especially in laptop motherboard and also in computer motherboard, in order to gain space in the motherboard. Okay, that's why they use this resistor. And of course, the same working principle. This resistor here is same as this. Okay, so here, as you can see, we have ceramic capacitors. Okay, these 4 components are ceramic capacitors, as you can see. So let's go to page 2. Let's see what we have here. So of course here we have an IC. All those are resistors. We have ceramic capacitors, and here, as you can see, this is a bridge. Okay, this is a bridge, and over here, as you can see, this symbol is for crystal oscillator. Okay, this is crystal oscillator. So let me zoom a little bit. So this is crystal oscillator, as you can see here. Its reference in the motherboard could be Y or X. So this reference oscillator generate a frequency, or generate a frequency. Okay, so here, as you can see, we have amplifier, as you can see here. So this here we have a switch. So this is the symbol for a switch. As you can see here, we have a switch with many pins, as you can see. So this point here, as you can see over here, so as you can see, we have here the VCC core. Okay, this is the voltage for the CPU, the working voltage for the CPU. And here we have this pink circle or dots, means all this connection are connected together. Here, as you can see, this is a ground, but there is 2 types of ground. This is basically a digital ground, and there is another ground that we called it analog ground. Of course, there is a chassis ground and others, but in the computer motherboard you will find just a digital ground and analog ground, and of course sometimes a chassis ground. So here we have an IC, as you can see here, and here we have an amplifier, as you can see. This is basically an amplifier. Here for this IC we have here the V in, and here we have the V out, we have the ground. Okay, this connector means, as you can see here we have another bridge, or we can call it a test point. You can check or test here. For example, here we have 3.3 volts. So you can check here whether you get 3.3 volts or not. So here, as you can see, this is the PCH. As you can see, this square means the PCH, and here we have the VR, and over here we have inductors. So this is resistors here, and this is inductor. So please pay attention, do not confuse between resistors and inductor. Okay, and of course here we have the ceramic capacitor. We called it sometimes PF capacitors, means picofarad capacitors, because usually its capacity is in picofarad. That's why we call it PF capacitors. So here we have another chipset, as you can see. So as I told you before, you can know whether this IC is a chipset or a normal IC by this squares inside or rectangular inside it. Those rectangular means controllers. For example, for the ICH, it contains many controllers. A controller for USB connector, a controller for HDMI connector, for VGA connector, for network connector, for RJ45 connector, etc. Okay, and also for BIOS, a control for BIOS that controls the BIOS. That's why you will find many rectangular inside. It means this is a chipset, but for the IC you will find just a square like this or a rectangular. But for this, it's not an IC, it's what? This is a connector. Okay, and this is basically a connector, as you can see, HDMI connector. Here we have its voltage 3.3 volt that pass through a resistor in order to reduce the current. Okay, here basically we have a MOSFET. This is a MOSFET, not a transistor. Okay, so the MOSFET you will find like a diode over here. We have a diode here, and we have here this row. Okay, means this is a MOSFET. So for the IC, I want just to add for the IC that you will find two references. This reference over here and another reference here. So this reference is its reference in the motherboard. As you can see, we have here UT9. But this is the part number. If you want, for example, if you find out that this IC is burned out or failed, you can replace it or change it using the same part number. So here, as you can see, we have MOSFET. So this is a MOSFET with 3 terminals, source, gate, and drain. Okay, and here we have the T-point or bridges. Here, as you can see, we have diodes. This is basically diodes. Okay, this is a normal diode with cathode here and anode here. Okay, so over here, as you can see, we have a double diode. This is basically a double diode. As you can see, we can call this a xeno diode. So this is a diode with 3 terminals, as you can see, 1, 2, and 3. Okay, we have here another double diode. This symbol is for connector. Okay, so here we have MOSFET, and over here this is basically a transformer. We can see that this is a coil, a double coil, but this is a filter, like a transformer used as a purpose to filter the signal. So here this is a connector. As you can see here, this is RJ45 connector. Okay, as you can see here, we have RJ45 circuit. This is a connector that we use to connect the RJ45 cable or Ethernet cable. So here, as you can see, we have ceramic capacitors, and this is electrolytic capacitor, a polarized capacitor, as you can see, with plus and minus. So we call it electrolytic capacitor, polarized capacitor, or even chemical capacitor. Here we have diodes. So here we have inductors. As you can see, we have other inductors over here. That's why I say to you, pay attention. This is inductor, not a resistor. So basically you can differentiate between it easily. For inductor, you will find as a reference L or PL, but for a resistor you will find R or PR. So guys, sorry, I'm a little bit sick. That's why my voice is a little bit, it's not good, but no problem. I will make this video because this video is in my to-do list. So here we have other network resistors, as you can see. So this also seems to be a network resistor, as you can see, 4 resistors. Okay, but here this is just a normal resistors, one next to other. But here this is just one block. Here these resistors are separated, and here one block. So here we have amplifiers, as you can see. This is an IC. Here this resistors, basically when you find resistors, so let me zoom a little bit. when you find resistors like this here, when you find a power here above it, and resistor like this, and another capacitor that is connected to the ground, and of course another resistor here, or any component. Sometimes it could be also a fuse or a diode. So we call this a pull-up resistor. This is a pull-up resistor. So you can look for pull-up resistors in Google. This is a very interesting topic that maybe in the future I will make a video, a special video for this kind of resistors. Very, very interesting resistors. So here we have MOSFETs. As you can see, this is MOSFETs. We have Q, reference is Q. We can see that those resistors also are pull-up resistors. Here, as you can see, we have a chemical capacitors. This is basically this chemical capacitors or electrolytic capacitors has two characteristics. So the capacity in microfarad, here we have 150 microfarad, and the voltage 6.3 volts, as you can see. So always the maximum voltage of this capacitor have to be greater than the voltage that we have here, or that we should get. So basically these capacitors, chemical capacitors or electrolytic capacitors, are used to filter the current. This is a filtering component in order to get a continuous voltage. But for this also, they do the same thing, filtering purposes, but they filter the noise in order to get a pure signal. So here we have a transistor. So this is transistor. This symbol is for transistor, as you can see, and this one is for MOSFET, and over here we have LED, light emitting diode. Okay, so this is LED. Okay, so over here we have Zener diode. Do you see the symbol for the Zener diode? This is its symbol. And normal diode, here we have a normal diode like this one. And of course this is what? This is a chipset. Why? Because we have many controller inside it. So guys, when you find like this mark here, means those pins are not connected or no connection. As you can see, we have here even NC, means no connection. Of course, here also we have no connection. Okay, this one also is not connected, as you can see, NC. So here we have power. This is basically a chipset. Here we have power, means the whole control. This whole control is for what? Is for power. Okay, so here we have just ceramic capacitors. Here we have resistors. Okay, let's go to the next page. So network resistor, inductors, resistors, MOSFET, double diode. So this is basically a basic circuit that you can find in every laptop without MOSFETs. Of course, we have the IC here. We don't have MOSFETs over here because the power is just 1 or below 1 or even 1.1 volt. The designer, they don't use the MOSFET. Okay, so we have just IC, we have inductor and ceramic capacitors. They don't use also the capacitor, the chemical capacitor or electronic capacitor is missing here, but no problem. Okay, we will get this voltage, but for the complete, the entire circuit, we find here MOSFETs, inductor, and we find current sense resistor and electrolytic capacitors in order to filter the current. So here the same working principle. We have just 3.3 volts. Okay, so this is another reason why we don't have here MOSFETs and electrolytic capacitors and current sense resistor, because we have just here as input voltage 3.3 volt. This always, as you can see, this voltage is already filtered and adjusted. But when you have a 19 volt, the main voltage, you should have, of course, here electrolytic capacitor in order to filter voltage, MOSFETs, current sense resistor. Okay, so here we have just IC, inductor, and capacitors. So here we have another type of MOSFET. This is basically 8P MOSFET. This is the most common used MOSFET in computer motherboards. Okay, 8-pin MOSFETs. So always the 4 pins that are connected together is drain, and the 3 pins are source, and over here we have the gate. But the same working principle. An 8-pin MOSFET has a same working principle in terms of testing as a 3-pin MOSFET, but its purpose is a little bit improved. So that's it, guys. So this schematic is already posted. I upload the schematic already in my Patreon page, so you can check for anyone who wants to download free schematics. This is entirely free, 100% free. You can just join me on my Patreon page, where you can find many schematics, and of course where you can ask me about any schematic you want. Of course I upload there a free schematic, okay, that I find free in the internet, and I buy some of that schematic, but I upload it for you just for free, 100% for free. You can you should join me in the Patreon page, and you have a freedom on downloading anyone you want and discover more unique content, okay? And of course, guys, please don't forget to subscribe if not already subscribed, to share the video for other people like you, and of course to like the video, because guys, the like motivate me to create more and more videos, and of course better videos. And finally, my mic, because many of you ask me you have a problem with the sound with your mic. So fortunately I buy another mic now. I hope that the sound is good, and of course thank you very much. See you in the next video.